study about the frequency response analysis of control systems. Whenever we want to find out the response of a control system, response means the output of the control system. So whenever we want to do some analysis of a control system, what we do? We apply certain input signals to the system, and then we see that what is the output of the system for these various inputs. Now here we have to study the we want to study the frequency response analysis. So what is the frequency response of a system? So the frequency response of a system is defined as it is a frequency dependent function which expresses how a sinusoidal signal of a given frequency which is applied on the system input is transferred through the system. So this is a system, and to this system we apply an input and then we get an output. So this is our input and it is the output. Now input, it is also known as the excitation, and output, it is also known as the response. So for frequency response analysis, the frequency response is a frequency dependent function. So what on what it depends? On the frequency, that is omega. Omega is the frequency. So this frequency response will be a frequency dependent function, and it expresses that how a sinusoidal signal. Now this sinusoidal signal, it is a time varying signal. So this input, or we can say the excitation, it is a sinusoidal signal, and this sinusoidal signal of a given frequency, let us suppose omega, and it is given as a system input, and how this input it is transferred through the system, it is known as the frequency response of a system. So it is the definition of the frequency response, that it is a frequency dependent function, that is omega, which express that how a sinusoidal signal is going to be transferred through the system. Okay. Now the input, as we have said, that it is a sinusoidal signal, so it will be a time varying signals, and these time varying signals, they can be considered as a sum of components. Okay, when we take Fourier series or Fourier expansion of this sinusoidal signal, then we will see that it is composed of various components, and each of this component, it is a frequency dependent function. So the time varying signals, can be considered as consisting of sum of frequency components. So one signal, it will be a sum of various frequency components, and each of these frequency component is a sinusoidal signal. So a time varying signal, that is our input, it will be a sum of frequency component, and each of the frequency component is a sinusoidal signal which is having certain amplitude and a certain frequency. Okay. Now the frequency response, what it does, now the frequency response, it expresses that how each of these frequency component it is transferred through the system. Okay. So these, out of these frequency components, it may be possible that some of the frequency components they are attenuated, or they can be modified, or some noise can be introduced, or there can be some phase difference. There may be some modifications which can be caused when these frequency components they pass through the system. So the output which we will get, it will be something different, because some modifications has been done while these frequency components are transferred through the system. So some of the components, they may be amplified, others may be attenuated. Attenuated means they are suppressed. Okay. Attenuated, and there will be some phase lag through the system. Okay. So what this frequency response is doing, it is transferring a sinusoidal signal, and this sinusoidal signal is applied on the system input, and then it is passed through the system. So the frequency response is expressing that how this is transferred, whether it is amplified, whether it is attenuated, or is there any phase difference in this signal. So this frequency response, it can be used in the analysis and the design of the control systems, because it is showing us that how the time varying signals is passed through the system. So the frequency response, it is an important tool for analysis and design of control systems. So this frequency response is, it is playing an important role. It is very important for the analysis and design of control systems. So how we can obtain this frequency response? The frequency response can be determined, it can be found experimentally, or from the transfer function of the system. So we can find out the frequency response of a system by some experiments, or we can obtain it from the transfer function of the system. it can be represented both graphically as well as a mathematical function. Okay, so you can express the frequency response of a system graphically also and as a mathematical function also. So if we see that we were having an input, okay, a sinusoidal function, and it is composed of various frequency components, and suppose this is a frequency component, this is at frequency, suppose it is first frequency, and we are getting the output as, okay, this is our output. So this is the system, and on the system we are applying the input and getting an output. Input is xt and this is yt. So this is our yt output and this is our input xt, and it is on one frequency. Now for second frequency the output may be different. This is frequency second, and for this we are having some different output. So frequency response is telling us that at what frequency is different, and depending upon the frequency what is the output. So our output will be a function of the frequency. Okay, now if we take the control systems, if we study about the control systems, so for control systems the frequency response analysis can be done by three methods. There are three methods by which we can do the frequency response analysis of the control system. First method is polar plots. Okay. Second method is Nyquist stability criteria. And third is Bode plot. Okay, so these are the three methods by which the frequency response analysis of the control systems can be done. And through the frequency response analysis, we can find out the stability of the system also. So these methods can also be used to find out the stability of the control systems. So I hope this video is clear to you that what is the frequency response analysis and how we can do the frequency response analysis of the control systems by these three methods. In our next videos, we will going to study these three methods one by one. I hope this video is clear to you. Thank you.